Hi, welcome back. This is Professor Ridge, and today's lesson on 6.2, rational expressions and functions. We're going to add and subtract. So just like adding and subtracting fractions, what's the first thing you got to consider when you want to add, say, like 3/5 plus 1/5? And hopefully you're saying common denominators. So if those are both the same, we just leave it alone, and then we add the numerators. And we get 4/5, and then you see if you can reduce. So that's the exact same rule for polynomials. If the denominators are the same, you leave the denominator alone, and you just add the numerators. Okay, so let's try a few. Number 10, 2/5n plus 8/5n. The denominator is the same, so you just write it down, and then you're going to add the numerators. So we get 10/5n, and of course then we look to see if we can reduce. So we can factor a 5 out of 10, cancel it, get 2/n. Okay, so on this one, a plus b, denominator is the same, just write it down. The numerators, a minus 5b plus a plus 7b, combine like terms, so we get, here, write it over here, we get 2a minus or plus 2b. We factor the 2 out. And you get 2. Now subtracting, no different than adding. If you have common denominators, you just subtract the numerators and leave the denominator alone. But with polynomials, right, you got to be careful when you subtract two polynomials. You got to remember you got to distribute the minus sign and then add or combine like terms. So on this one, right, the denominators are the same, y minus 2, and then I'm going to subtract the numerators. But remember, on polynomial, you got to distribute that minus sign. So we're going to get 4y plus 2 minus y plus 3. And now we combine like terms, and we get 3y plus 5 over y minus 2. And then that doesn't factor, nothing cancels, so we're done. Okay, so let's try, what about if the denominators are not alike? So if I wanted to do, say, like 3/5 plus 2/3, what you have to do is find what's the LCD of 3 and 5. And so the way I do it is, I think, okay, I want the LCD is going to be 15. So 5 times what is 15? So I'm looking at the denominator here. So 5 times 3 is 15, and then you got to put in your factor. You can't change the number, so you got to make this the same. 3/3 is 1, so I'm allowed to multiply any number times 1. So if I multiply the bottom by 3, I got to multiply the top by 3. And then for 2/3, I want 15 on the bottom, so I got to put in a 5 on top. So now I get 9/15 plus 10/15, which gives me 19/15. Okay, so I'm going to use that same technique for factoring, for adding polynomials or rational expressions. All right, let's review how to find a least common multiple or least common denominator. Okay, so to find the LCM, you're going to find the prime factorization of each expression, and then the LCM is going to be formed by a product that contains each factor the greatest number of times, now here's the keyword, in any one factorization, one of the prime factorizations. So we're going to factor each number, and then you're going to look for each prime factor that occurs, you're going to look for the most times that it happens in one of the factorizations. All right, so let's try some on the next page. Okay, so let's find the LCM for 12x cubed y squared and 18x squared y to the fifth. So 12x cubed y squared is equal to 2 times 2 times 3 times x. We'll just leave those as powers for the variables. And then 18x squared y to the fifth, we'll do 2 times 3 times 3 is 18 x squared y to the fifth. So the LCM will be 2. You got 2 2's in the 12 and 1 2 in the 18, so you need 2 2's because you take the most times 2 happens in one of the factorizations. So it happens twice in 12. So I need 2 2's. And then 3, I got 1 3 in 12, 2 3's in 18, so I need 2 3's. Now for x, I have 3 x's, x to the third power in the first one, and x squared in the second one, so you need the most times x happens in one factorization, which would be 3. And then for y, you need the most times y happens, so in the second one it happens 5. Notice I didn't say the total number of times y happens, so I don't take 7, I take 5. Just like I didn't take 3 2's, I only took 2 2's. So then you multiply that out and you get 36 x cubed y to the fifth. Let's try one more. So let's try these two. So the first one's going to be factors of 15 that subtract to 1. Oh, I'm sorry. I meant to do 2. So that'll be 3 and 5. So that would be plus 5, 3. And then for the second one, that's the difference of squares. So it's x plus 5, x minus 5. So our LCM will be, you need 1x plus 5, 1x plus 5, so I need 1x plus 5 because it's the most times it happens in one factorization. I need 1x minus 3, and I need 1x minus 5. So that's my LCM. I have 1x plus 5, 1x minus 3, and 1x minus 5 all multiplied together. Okay, so now let's try to add some of these now that we can find a common denominator. So let's start off with number 30. 8 over 9y minus 5 over 18y. So our first thing is to find the LCD. So we do what we did up there. 9y is 3 times 3 times y. 18y squared is 2 times 3 times 3 times y squared. So the LCM will be, I need 1, 2, 2 3's, and y squared. So it's 18y to the second. Now I got to build up this fraction to be 9y squared. And okay, so here's 9, 3 times 3, so I'm missing a 2. So I need to put in a 2 to get the 18. And to get y squared, I need another y. The second fraction is already 18y squared, so I leave it alone. So now I got 16y over 18y squared. And now I can add them. I got common denominators. Add the numerators, or subtract the numerators. And it doesn't factor, so actually I am done. Okay, so in practice what I do is I just factor both the denominators right in my problem, like this. Okay, so now I look at the denominators to say, well, okay, what's my LCM? Let's see, I need, so off to the side I kind of figure out my LCM. So my LCM is going to be, I need 1a plus b, or it would be LCD in this context. I need 1a plus b, and I need 1a minus b. I have 1 in each of these, so I only need 1. Greatest number of times it happens in one of them, not combined, one of them. So that's my LCD, which is just the first one I can leave alone. So I just write it down. The second one, I got to build it up, and I'm going to have a plus b over a minus b. And I'm missing, to get the LCD, I'm missing, so I think of that, okay, I have an a minus b, what's missing? Okay, put it in. So I'm going to put in the a plus b into bottom, top. Now, the bottom you leave alone, and then you got to distribute the top. So this is what I usually do. I make one denominator, and then I'm going to do 5ab plus, and then I go ahead and distribute this. So I'm going to get a squared plus ab, well that's a plus b times a plus b. So that's 2ab, just to save some space. You can do that off the scratch work if you need to. And then combine like terms. So I got a squared plus 7ab plus b squared over a plus b, a plus, oh I copied that wrong, it's a minus b. It doesn't matter which one's plus, which one's minus, as long as you got both. Alright, so there you go. Let's try a couple more. Number 39. So again, I'm just going to factor factors of 20 that add to 9. So that's 5 and 4, both plus. And again, in practice what I do is I usually leave space there to build up my LCD. So I kind of combine some steps here. So factors of 12 that add to 7. So let's see, that would be 3 and 4. They're both plus. So what's my LCD? My LCD is going to be, I need 1x plus 5, 1x plus 4, 1x minus 3, no that's plus 3, and then that's it. So I have 1x plus 4 in both of them, but the most times it happens in one list individually is just once. So I just need 1x plus 4. Okay, you got to understand that. Alright, so for my first fraction I already have the x plus 5, x plus 4. I'm missing x plus 3, so I got to build it. So I put it in. Whatever you do the bottom, you got to do the top. Because you were putting in a factor 1, which doesn't change the value of the fraction, it just makes it look different. And we want it to look different but be the same number. Alright, and then the second one I have the x plus 3, which is right here, and the x plus 4, so I'm missing the x plus 5. So I put in 1 on the bottom, 1 on top. Now I'm going to make one big fraction with the common denominator. I'm going to distribute the top. So that'd be x squared plus 3x. And then remember this minus 4. I'm going to make that minus 4 and then distribute the negative 4. So it'd be negative 4x, negative 20. Combine my like terms. And then factor the top and see if I can reduce. So the top's going to factors of 20. This subtract. Factors of 20 that subtract to 1. So we got 5 and 4. The bigger one will be negative. The other one will be positive. So the x plus 4's cancel. And we end up with x minus 5 over x plus 5, x plus 3. And that should be right. Yep. Okay, I want you to learn this trick here. If you have a negative in front of a fraction, you can put a negative on top, or you can put it on bottom. They all give you the same answer, because if you did the opposite of 6 divided by 3, you get negative 2. If you did negative 6 divided by 3, you still get negative 2. And if you did 6 divided by negative 3, you would still get negative 2. So they all give you the same answer. Now, and then one other thing to remember is that when you subtract or change the order of subtraction, it gives you opposite signs. So 5 minus 3 is 2, and 3 minus 5 is negative 2. So they're not equal, they're opposites. So if you can think of it a couple ways. You can factor out a negative 1. The negative 1 times b is the negative b. The negative 1 times the negative a is the positive a. So either way. So when you switch the order, so I'm going to combine both these things, because I noticed that I have x squared minus 16 and then 16 minus x squared. I want to switch the order of one of them. And what I do is I'm actually going to take that minus sign and I'm going to put it on the bottom. And normally I don't show the step, I just go straight. And then this, using the rule here, I'm going to distribute the minus sign and switch the order. So it'll be x minus 7 x squared minus 16. Now you got common denominators, so we just combine like terms. So we get on the numerators x minus 7 plus x minus 1, which gets you 2x minus 8. And of course you can factor, so I get a 2 out. The bottom is a difference of squares. And we get 2 over x plus 4. Okay, so on this one, 55, we don't have that minus sign there. I'm still going to use the same trick. I'm going to take the second one and switch the order. Y to the fourth minus 81, but I can't just switch the order without fixing it, right? That gives you the opposite sign, so you got to put the opposite there. Now I'm going to take this and just move it up to the top. So y squared minus 5, and then it's going to be minus 4 over y to the fourth minus 81. which gets me y to the second minus 9, and the bottom is y to the fourth minus 81, and I'm going to, the top's the difference of squares, so we're going to get y plus 3, y minus 3. The bottom we get y squared plus 9, y squared minus 9, which, if you remember, the top, well, the y squared minus 9 is y plus 3 times y minus 3. So if I left the top, if I didn't factor it, I could have seen that, hey, that's going to cancel. So I'm left with 1 over y squared plus 9. I just didn't feel like rewriting it. Okay, so that's good. So that concludes your lesson for 6.2. Go to my math lab and complete your exercises there, and I'll see you next time.